Hi everyone, welcome back to Algebra 1, where today's topic is going to be about solving one-step inequalities. Before we talk about how to solve them, we need to define what an inequality is, and an inequality states that two quantities are not equal, as opposed to what we've been learning about equations where two things are set to be equal. Inequalities are defined by the two quantities not being equal. And then the solution that we are going to find is any value of the variable that makes the inequality true. There are four ways to compare two quantities, and this first one is the symbol for less than. And we have here illustrated that A is less than B. I'll write it down. And we can have something marked as greater than. And this is a symbol right here. And we have an example illustrated that A is greater than B. You can also have something less than or equal. And this little line denotes that it's equal as well. So here we have following that A is less than or equal to B. And then we can also have greater than or equal. And I put over here that we need to remember that A can never equal B. Now, how do we graph these inequalities? Oops, excuse me. We have an example where the algebraic expression is x is going to be less than 5. When you write it out, it's all real numbers are less than 5. How do we actually graph it? We go to the number line and we find where 5 is. And if it's strictly less than, one moment, you go to the 5 and then you demarcate, that it's anything less than 5. Now, what if it's saying that x is greater than -1? Literature written down, this algebraic expression is represented by writing down that all real numbers are greater than -1. You would then, to graph it, go over to the number line, find -1. And you'd mark it with an open circle, and then you'd draw to everything that's greater than -1. Now, what if you had x is less than or equal to 1/2? Literally written down, it's all real numbers are less than or equal to 1/2. To graph it out, you would go to where 1/2 is. So 1/2 is, according to the number line right here. But you would have this circled. You'd have it filled in, and then everything less than, please don't erase, would be represented by the arrow going to the left. And then we have x is greater than or equal to 0 written down. It is represented by writing all real numbers are greater than or equal to 0. So in the number line, you're going to find 0. You can start with a circle, but if it's the equal, you're going to put it as filled in, and you're going to make the arrow go towards the right because it's all real numbers that are greater than or equal to 0. You're going to do that. The solid circle means that it's equal to that number on the number line. If it is a hollow circle, that means that number on the number line is not included everything to the left or the right of it is, though. Now, how to solve one-step inequalities. We're going to isolate the variable like we did in solving an equation using inequality properties, and we're going to perform inverse operations that we already do when we are solving equations. So there are several properties for inequalities. They are, They are addition, subtraction, multiplication, and division. So for addition, we have an example where we have A is less than B. And I'm using less than in the examples, but I wrote down here that it's also true for inequalities with symbols of greater than, less than or equal to, and greater than and equal to. But specifically for addition, when you have, in this example, A is less than B, you will either, you're adding the same number to both sides of the inequality, and by doing this, it still makes it true. That's a property of the addition property. So you're going to add C to one side and add C to the next side. It's still true as if you didn't add to either. So an example here is 9 is less than 13. If I add 2 to both sides, we have 11 is still less than 15. The subtraction property is saying that subtracting the same number to both sides of the inequality, still it's true. So if I subtract C from the left and C from the right, the inequality is going to be just as true as if I didn't do any subtracting on either side. So for example, I have 9 is less than 13. If I subtract 2 on one side, it's 7. If I subtract 2 on the other side, it is 11. It's still true because 7 is still less than 11. The multiplication property is stated that multiplying the same number by a positive number to both sides of the equation, still it leaves the inequality true. Highlighted, and I want to make note that positive number. If it's negative, it's a different situation. And we'll go over that in a moment. But visually, if you have an inequality that's original, if you multiply both sides by the same multiplicand, it's still going to be true. An example is if we multiply 9 times 2 and then 13 times 2 on the other side, when we fill it out, 9 times 2 is 18, and then 13 times 2 is 26. It's still true, like the original 9 was less than 13, 18 is still less than 26. And lastly, the division process is that dividing the same number by a positive number to both sides of the inequality, still it is true. Again, we're going to highlight that it needs to be positive. For the example here where we have 9 is less than 13, if we divide both sides by 2, 9 divided by 2 is 4.5. And then 13 divided by 2 is 6.5. 4.5 is going to be less than 6.5. I want to also make known that this C has to be greater than 0. Actually, hold on one moment. Yeah, greater than 0 because you can't multiply it by 0 and you can't divide anything by 0. So now let's do some examples. We have x plus 10 is less than 15. Remember, in how to solve the inequalities, we're going to isolate the variable using our inequality properties, and we're going to perform inverse operations. So here, our variable is not isolated. So how can we isolate it? We're going to use the subtraction property and subtract 10 from the left. So we have to subtract 10 from the right. And then we end up with x is less than 5. Alrighty. So the answer is, if we go here, any value of the variable that makes the inequality true. So this x is any variable that makes it true. So anything under 5 is going to make this true because it's less than 5. So that's 4, 3, 2, 1, etc. 6 would not make it true because that's greater than 5. All right, let's move on. So we have d minus 5 is greater than negative 6. We need to isolate it. How can we isolate it? We can use the addition property because we have a negative. So plus 5, d is greater than negative 1. For this one, we have the variable being multiplied by something, so we can use the division property and divide it. So divided by 4, but it's a positive 4. So x is going to be greater than negative 3. And then for the last one, we have d over 3 is greater than 5. To isolate this variable, we have to use the multiplication property and multiply it by 3. So we have to do that on the right side as well. D is now isolated. And the answer is going to be d is any variable that is greater than 15. Now, there are a couple of properties of inequalities when we are multiplying or dividing by negative numbers. And I'll put that in highlight, negative numbers. Now, for multiplication, let's see if this, bear with me, guys. Okay, now, the literature states that multiplying the same number by a negative number to both sides of the inequalities still is true. Hold on. But we must reverse the inequality symbol. So I'm going to highlight that. There's a but. So here we have a less than symbol. If we are multiplying by a negative value of c, then the answer we know is going to be a greater than value. And we can show that here. So we have 5 is greater than 2. We're going to multiply both sides by negative 2. So then we have the answers to be negative 10. Since it's a negative multiplicand, we know that we automatically are going to flip it. Let me put it in red. The other way. And then we're going to do the math here. So that's negative 4. And that does make it true because negative 10 is a smaller number than negative 4. It would never be greater than. Negative 10 is never going to be greater than negative 4. Now for division, dividing the same number by a negative number to both sides of the inequalities. Still, it is true, but must reverse the inequality symbol, same as before with multiplication. So if this c is negative, then we automatically know that the answer is going to be flipped. So I'm going to put here that the answer is going to be flipped. So when we have in our example, 50 is greater than negative 25. If we decide to divide both sides by negative 25, 50 divided by negative 25 is going to be negative 2, but we're automatically going to flip it. And then 25 divided by negative 25 is negative 1. That is true because negative 2 is always going to be less than negative 1. And let's go ahead with some examples. So we have, let me go back to blue. Negative 9x is greater than 45. We have to isolate this variable. It's being multiplied by a negative number, so we have to divide it by a negative number. Divided by negative 9, so we have to do the same thing on the right side. This is canceled, and we're left with x, so it's isolated. But we have to know now, since it was by a negative number, that we have to flip this the opposite way, and then we solve. That's going to be -5. Alrighty, and then for this last one, we have 10 is less than or equal to x over 3. We need to isolate this variable, so we're going to multiply it by 3 since it's being divided by 3. Then we have to do the same thing on the left side. That's going to be 30. Let's pretend, guys, that this was a negative, because that's the whole point. So we're going to put negative and negative. So since this was multiplied by -3 on both sides, I have to flip this way and then finish solving the problem. This can now be canceled out, so x is isolated, and that's the answer we have. I will see you guys in the practice problems. The link to those videos are in this video's description.